All right, ladies and gentlemen, today we're going to be going over another gas law called Dalton's law. So what Dalton's law states is the total pressure of a closed system is equal to the sum of all the partial pressures. So all the partial pressures of the gases in that closed system, the sum of those is equal to the total pressure. So we have P total pressure is equal to pressure of the first gas, the second gas, the third gas, all the way to the last gas that's in the closed system. The sum of those is equal to the total pressure. First problem we're going to do together is calculate the partial pressures of 5.120 liters of hydrogen, 2.401 liters of oxygen, and 17.479 liters of nitrogen in a container with a total pressure of 93.12 kilopascals. First thing we do is grab our equation. So we have pressure of the first gas over the volume of the first gas is equal to the ratio of the total pressure over the total volume. We rearrange that because we have the partial pressures of our gases that we're looking for. So we have the partial pressure of the first gas is equal to the quantity of the volume of the first gas divided by the total volume times the total pressure. Write down our knowns. So 5.120 liters of H2 hydrogen, 2.401 liters of O2 oxygen, and 17.479 liters of N2 nitrogen. We need our total volume for our equation there. So we add those together, we get 25.000 liters in our total volume in our closed system. Then we're going to plug in what we need for the equation. So we need the partial pressure of hydrogen first is equal to the volume of hydrogen divided by the total volume times the total pressure. Plug in our knowns. So partial pressure of hydrogen is equal to 5.120 liters divided by 25.000 liters times 93.12 kilopascals. Calculate that out with sig figs and we get 19.07 kilopascals. Now, are we done? No, we need to find the partial pressures of all of the gases in our closed system. So we need the partial pressure of oxygen and nitrogen. I won't show you how we're plugging those in, but it's the same way that we did with hydrogen. Just plugging in a different value. Instead of 5.120 here, we're going to plug in 2.401 for oxygen, 17.479 liters for nitrogen. We get those on our calculator, get the sig figs, we get partial pressure of oxygen is 8.943 kilopascals. Partial pressure for nitrogen is 65.11 kilopascals. Those are our answers. How do we know that we did this right? We're going to add all of our partial pressures together because they should equal our total pressure for the system. So we add those together, we get 93.12 kilopascals. That's the same as we're given in our problem. We're good, we did it right. Next problem we're gonna do together in class. So calculate the partial pressures of 726.9 milliliters of fluorine, 931.1 milliliters of chlorine, and 1.158 liters of nitrogen in a container with a total pressure of 2.046 atmospheres. Write that down in your notes. We're going to do that together. Next one we're going to do together in class, calculate the partial pressures of 125.26 milliliters of nitrous oxide, 504.12 milliliters of oxygen, 251.02 milliliters of nitrogen, and 1.0000 liters of nitrogen dioxide in a container with a total pressure of 1.0415 atmospheres. Write this one down. You're going to do this with a partner. And then you're going to write this next one down with the do with a partner in class as well. That's all we have for today. Look forward to talking to you guys in class. Take care.